Example 1, part A, we are given the rounded value. We're also given the rounding, and we're asked to work out the upper and lower bounds. In other words, the largest and smallest possible value that the actual value can be. So, the starting point is to look at the rounding. Now the rounding is to 2 decimal places. So 2 decimal places means to the nearest hundredth, remember. The second decimal place is the hundredths column. So it's to the nearest hundredth. In other words, 0.01, the nearest 100th. So that's important. Now remember from our introduction, in order to get the upper and lower bounds, we need to work out the error first, because we're going to add on the error to get the upper bound, and we're going to subtract the error to get the lower bound. So the next thing we need is the error. And the error is the rounding divided by 2. So the rounding is 0.01. We divide that by 2. And that's going to give us 0.005. Okay, so that is our error. We're now going to get our bounds. So we'll start with the lower bound, LB. So the lower bound, remember, is the rounded value. Subtract the error. So that's going to give us 5.235, and that's going to be meters. And then the upper bound, it's always the rounded value plus the error. So that's just going to give us 5.245 meters. Okay, and that's our answer for part A, lower bound and upper bound. So what that means is the actual value before it was rounded could lie anywhere between these 2 particular values. Okay, part B. So part B, we have a rounded value of 8.6 seconds. And it's been rounded to 1 decimal place. Now, first of all, we have to understand what 1 decimal place means. It means to the nearest 1/10. Which is obviously 0.1. 1/10 means 0.1. 1 decimal place means the tenths column. So, to get the upper and lower bounds, we need to work out the error first. And again, the error is always the rounding divided by 2. So it's 0.1 divided by 2. Just going to give us 0.05. And now we're in a position to work out the bounds. So, to get our lower bound, we take our rounded value and we subtract the error. So 8.6 subtract 0.05. So that's going to give us 8.55, and that's going to be seconds. And then our upper bound Well, we're going to take our rounded value and we're going to add on the error. So that's going to give us 8.65 seconds. Okay, and that's our answer for part B. So in other words, before the quantity was rounded to 8.6 seconds, the actual quantity could lie anywhere between 8.55 and 8.65 seconds inclusive. Okay, part C. Okay, we have a rounded value here of 5,600 millimeters, and it's been rounded to the nearest 100 millimeters. So the rounding is to the nearest 100. Now, again, to get the bounds, we have to work out the error. And the error is always the given rounding divided by 2, so it's just 100 divided by 2, which is going to give us 50. And then we're going to work out our bounds. So we'll start with a lower bound. So the lower bound is the rounded value, subtract the error. So it's going to be 5,600, subtract 50. So that's going to give us 5,550. And the units are going to be millimeters. Okay, the upper bound then, we will take the rounded value and we will add on the error. So it will be 5,600 plus 50. And that's going to give us 5,650 millimeters. And again, that's our answer for the bounds for part C. So before the actual value was rounded, the actual value would lie somewhere between 5,550 millimeters and 5,650 millimeters inclusive. Okay, part D. So part D, we appear to have a weight 24 kilograms. And it's been rounded to the nearest kilogram. Okay, to the nearest kilogram means to the nearest 1 kilogram. So again, to get the bounds for this rounded value here, we have to get the error. So the error is going to be the rounding divided by 2. So that's going to give us 0.5. And now we can get the bounds. Okay, let's start with the lower bound. So the lower bound is the rounded value, subtract the error. So that's going to give us 23.5 kilograms. And then the upper bound, we take our rounded value and we add on the error. So that's going to give us 24.5 kilograms. So before the actual value was rounded, we can determine that the actual value must have been somewhere between 23.5 and 24.5 kilograms inclusive. Okay, last one, part E. So the rounded value is 5.0 seconds, and it's been rounded to two significant figures. Now again, this was the tricky one. What does significant figures mean here when it comes to rounding? Well, what you do is look at the last column. So the very last column is the column with a 0 in it, and then you have to ask yourself, what's the name of that column? That column is the tenths column. So you then take the unit value for the tenths column. So the unit value for the tenths column is 1/10 or 0.1. So in this case, we take the unit value for the last column, so the last column is the tenths, so it's going to be 0.1, 1/10. Okay, so to get the bounds, we need to work out our error. So the error is the rounding divided by 2, 0.1 divided by 2. So that's going to give us 0.05. And then we can get our bounds. So the lower bound is the rounded value, subtract the error. So that's going to give us 4.95 seconds. And then the upper bound, we're going to take our rounded value and we're going to add on the error. So that's going to give us 5.05 seconds. And those are the bounds for part E. So in other words, before the actual value was rounded, the actual value must have been somewhere between 4.95 seconds and 5.05 seconds inclusive.